In this video, we're going to talk about electric charge, potential, and field. Now, let's begin by talking about electrostatics. Electrostatics is the study of electrical phenomena that are associated with charges and charge systems at rest. So it can be divided into two, that is electrostatics. Electro talks about charges, while statics talks about something that is at rest. Okay, so having seen that, now a charge is produced. Of course, we know that a charge is produced when atoms of a substance either gain or lose electrons. Now, electroscope is an instrument used for detecting charges. That is, so we have some charging methods you can use to charge some substances. We have charging methods. We have one by friction. Now, when friction, it involves two neutral bodies acquiring charges each when rubbed over each other. So we say that is by friction. Example is when you get a four, that's a feather or something, or a wool or a silk, and you rub it over a glass rod. So it acquires charges. Number two is by conduction. This is when two bodies acquire charges by contact. So that is conduction. That is after contact, they acquire charges. Three is by induction. If you don't call it induction, you can call it nearness. Nearness. This is when a charged body is brought close without contact to a neutral body so that charges are induced into that neutral body. So the instrument that is used for detecting charges is called an electroscope. We have an example of a gold leaf electroscope. This is just a sketch having a brass disc and then insulator plug, a brass rod, then this is the gold leaf itself. Then this is just a glass bottle. This is just it. That's how. Now, how does it work? This is a very sensitive equipment. Okay. The object that needs to be tested is touched with the metal cap. If the leaves diverge, the body is said to be charged. And if there is no charge, the leaves of this electroscope will not move. Now, a positively charged object is brought near this metal cap. Then another unknown body is brought near this metal cap. If these leaves diverge further, we can conclude that that unknown body has a positive charge. If these leaves come closer to each other, then the charge of that unknown body is negative. That's what it means. So let's look at Coulomb's law. This law states that forces of attraction or repulsion exerted by a charge on another charge varies directly as the product of their charges and inversely to the square of the distance between them. Mathematically, we can say F directly proportional to Q1, Q2 over R squared. So directly proportional to the product of those two charges, then inversely proportional to the square of their distances. So Q1 is the test charge, Q2 is the unknown charge, R squared is the distance between them. If we substitute the proportionality sign, we have that F equal, we introduce a constant K, Q1, Q2 over R squared. We can write this as F equal to K using small letter q and then big letter Q over R squared. So whichever way is the same, just to differentiate both of them. Now this K, the constant, is giving us 1 over 4 pi E naught, while E naught is called permittivity of free space, and it has a value of 0.895 times 10 raised to power minus 12 Coulomb squared per meter squared. So, having seen that, let's look at some questions. So, before we look at some questions, let's look at electric field. Electric field E is a region where electric force is felt. So it can also be defined as force per unit charge. So E can be given as force per unit charge. Now, if we have, you can illustrate it saying this is a positive charge. You have something like this. If it is a negative charge, you have negative. These same lines, the arrow goes inside. The arrow goes inside. The arrow goes inside. Electric flux is these imaginary lines that shows the direction of the electric field or electric force. That's the electric flux. So if we say that electric field is equal to force per unit charge, remember that force on its own is giving us K, Q, Q over rho squared. If we divide both sides by small q, we'll have that force over Q is equal to K, Q, Q over Q r squared. This r cancels this r. What will be left is F over Q equal to K, Q r squared. Now, this is electric field, remember. This is electric field. So electric field is written as F can be represented as KQ over R squared. And you need to know that E, electric field, is dependent on point. You need to note that. Okay, for example, look at this question. It says, find the electric field at a point 20 cm from a charge of 30 microcoulomb and the force that the field will exert on a charge of 8 microcoulomb at that point. Take 1 over 4 pi, that's K, 1 over 4 pi E naught to be 9.0 times blah 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 blah. Now, the first thing we need to understand, let's say solution. We need to know that E is giving us K, Q over R squared. This K, we were asked to take it to be this. So what we're going to do is that the electric field due to E due to 30 microcoulomb, I beg your pardon, due to 30 microcoulomb charge is giving us 9, which is this 9.0 times 10 raised to power 9 times the charge, that is 30. Micro means times 10 raised to power minus 6 coulomb all over. What is the distance given to us? The distance is 20 centimeters, and we cannot work with that 20 centimeters. We need to convert it to meters, which will give us 20 times 10 raised to power minus 2. And remember, it is squared, so squared. All we need to do is to press our calculator. If we press our calculator, the electric field will give us 675,000 Newton per coulomb. You can put it in standard form and say 6.75 times 10 raised to power 4 Newton coulomb. Now, this is the field. Now, for us to get the force that is exerted due to 8 microcoulomb, the force that is exerted due to 8 microcoulomb. Remember, force is giving us Q and Q. You can say K, Q, Q over rho squared. So we can say 9.0 times 10 raised to power 9 times This one now becomes is 30 times 10 raised to power minus 6. We can now bring in the new charge, which is 8 microcoulomb. 8 times 10 raised to power minus 6 all over the distance. The distance remains 20 times 10 raised to power minus 2, all squared. When you press your calculator, F is 54 Newton. So that's the question and the solution. So another question we can look at is an electron and an alpha particle are spaced 10 raised to power minus 13 meters apart. What is the magnitude of the electrostatic force? Now here, we need to notice that solution. We need to notice that an alpha particle is represented by a helium atom which has 2 electrons. Now the charge on electron E, the charge on electron is 1.6 times 10 raised to power minus 19. The charge on one electron. So if for alpha particle, it means it will now be 2 times this value. So for us to get the force F is giving us Q over R squared. If you are to fix the values, remember our K is 9.0 times 10 raised to power 9 times the alpha particle, which is 2 times 1.6 times 10 raised to power minus 19. Then the other electron, which is 1.6 times 10 raised to power minus 19. The distance apart is 10 raised to power minus 13 squared. If we are to press the calculator, we'll get 4.6 times 10 raised to power minus 2. That's Newton.